Welcome back to Algebra 1 Honors. We're going to continue on in Chapter 9. This is Lesson 9-6, Wind and Water Current Problems. Okay? And really this is just sort of a special version of systems of equations. Okay? Just like the coin problems and the animal problems. Now, but what we're going to show you in this one, and we used it in the previous example, is how to use a table to organize your information. Now, we know that most of you can do many of these problems in your head. We also know that, particularly when you get into college or into harder classes, that there are going to be problems at some point that you cannot do in your head, and I don't care how smart you are. There will be a point where you just cannot do that. So you need to learn now, with the simpler problems, how to organize information so that when you finally hit that problem that you can't do in your head, and it's different for different people, you'll then have this tool to help you. Okay? So that's what we're going to do right now. We're going to use the table here to help us solve, and we're still going to write our equations, but we're going to organize our information here. So here's our problem, and it's one out of your book. It says a plane, there's my plane, don't laugh. My plane is traveling 8,400 kilometers. That's the distance, okay, in 7 hours, okay, and so that's going into the wind, okay. Notice it's when it is going, it's going into the wind. Then with a tailwind, that's up here, the wind's blowing it, pushing it along. It returns in 6 hours. So I'll put another label up here. This is my going, and this is returning. Okay? And it's going to come back faster because it's got a tailwind pushing it. It's going to take longer to go to that city because it's running into a headwind. The headwind's pushing against it. Okay? Now, so the distance is the same. That's one of the things you have to realize here is that the plane is going to some distant city. Going and coming, the distance is the same. The speed of the plane isn't necessarily. If there were no wind, it would be, okay, and no other obstacles and things. But the distance is the same. So we can go ahead and fill in up here. $8,400 for both of our distances, because that's how far, and it's kilometers. Okay. Now, let's see, with the tailwind, when it returns, so when it comes back here, with the wind, the time that it takes is 6 hours. Okay? And when it's going against the wind, I should have put that here, but you can see the picture, it takes 7 hours. And they're both in hours, not one in minutes, not one in hours, both in hours. Okay? Now, then we have to think about, we need to choose two variables here. The two variables are the speed of the plane without the wind blowing on it and the speed of the wind. Okay? So we need a variable for the plane, and I would suggest P for the plane speed, and we need a variable for the wind. How about W? Okay, for the wind speed. Now, when the plane has the wind pushing it, it's going to go not only as fast as the plane can go by itself, but it's going to have that little extra push from the wind. So the rate or the speed of the plane is going to be its own speed plus the push that it gets, the extra speed it gets from the wind. Now, coming back, it's going to be the plane speed, but the wind is pushing against it. So it's going to go a little bit slower because for every forward, the wind is trying to shove it backward. So it's going to be the plane speed minus the wind speed because the wind's taken away. So if the plane would normally go, say, 500 miles an hour, and the wind is 100, it's only going to make 400. Okay? Now we have to set up our equations. Okay? And what we know is that the rate, the speed that you're going, times the time that you go that speed gives you the distance that you go. So if you jump in your car and you go in 50 miles an hour and you go for 3 hours, that's 3 times 50, you've gone 150 miles. Okay? Kind of common sense. Now, so here's our two equations. this speed or rate times this time, so P plus W, that's our speed with the wind pushing us, times 6, times our time, equals the distance that we go right there. Then we have another one. The speed that we go against the wind times that times 7 also equals 8,400. Now, next step. You notice both of our distances are equal. So we can use what we call the transitive property that says if two things are both equal to the same thing, then they're equal to each other. Okay? So since these two things are equal, these two things must also be equal. So we're going to say P plus W times 6 is equal to P minus W times 7. Okay? Now we have to distribute our 6 and over here distribute our 7. So we end up with 6P plus 6W equals 7P minus 7W. Okay, and then we're going to, let's see, collect all our P's and collect all our W's. So we have, let's see, if we put all the P's over here, subtract 6P from each side, we get P over here, and let's add our W's. So we add 7W, add 7W here, and we get 13W equals P. Okay. Now the question is, what do we do at this point? And it took me a second because we still have one equation here and two variables. But we have a nickname, okay? We already have a built-in nickname here for P. See, here's P's other nickname right here. There's P, 13W. So now we can go back to one of our original equations up there, okay? And we're going to say, okay, where I had a P, I'm going to put in this name. And I like pluses, so I'm going to use my top equation. So I'm going to take my 13W nickname for P, and right here where P is, I'm going to put in my 13W. So then what I'm going to have here, and I'm going to, I'll erase here. And what I'm going to have is 13W plus W, 14W times 6 equals 8,400. Let's see, let's divide, go ahead and divide both sides by 6. That'll give me 14W equals what? Let's see.
1,400.
1,400, right? Divide both sides by 14. And we have the wind speed is equal to 100 kilometers per hour. Now, once we know the wind speed, then we can go back and substitute in and find our plane speed. Okay? So we know that the wind is 100. Okay? Let's go back to our original equation there. That's one of them. And let's put in the 100 for W right here and solve for P. So now we have P plus 100 times 6 equals 8,400. And then we'll divide by 6 and we get P plus 100 equals 1,400. Subtract 100 from each side, and P the plane speed is equal to 1,300 kilometers per hour. Okay, and that was our other variable that we were looking for. Yes, we have a question.
I have a question. I used to do that problem the exact same way until I analyzed it. You can actually make that problem more simpler and more relevant if you would divide before you do anything by 6 on the first one and 7, and then you're going to have P plus W and P minus W, and bingo. So maybe you would like to show them.
Okay. Mr. Kiger is kibitzing here, but let's show you another way to do this.
The easy, pleasy way to do it.
Here's an even easier way. Okay, what he just said is when we get our two equations here, P plus W times 6 equals 8,400, and P minus W times 7 equals 8,400. Said divide by 6 here, and we get P plus W equals 1,400. Okay, and if we divide by 7 here on both sides, we get P minus W equals 1,200. Okay, and now, instead of using substitution, this is the other way. Now we can do elimination. Okay, kind of neat, huh? You can do these problems at least 2 ways, and if you really want to torture yourself, you can graph it. Okay, now we've got W's that are opposite signs and coefficients, so we add, we get 2P equals 2,600, and the plane speed equals 1,300, which is what we got the other way. Okay, so one-way substitution, one-way elimination. I agree with you. This is an easier way on this one. Okay? Isn't that neat? 2 different ways to do the same problem.
And then just plug it in and you'll get your...
And then plug in the 1,300 right here. 1,300 plus what gives you 1,400. It's very quick to see what the wind is. All right? The wind is 100. Okay?
Beautiful.